Welcome back, students. In this video I'm going to show you how to perform accuracy assessment of the classified image or land use land cover map that you have previously created with you in the previous videos. So in order to be able to perform accuracy assessment procedure, you have to have the following inputs. You have to have your classification, the results of your classification, your classified image, and you have to have a validation data sets. For your information, you can go back to our lecture videos where you can learn about the requirements for both training and validation datasets. So, in our case, we have created three different classifications based on different classification algorithms. I will highlight some of these classifications. I will start with the maximum likelihood classification result. So here our results from the previous videos, and I also have created a validation data input. If you now turn on this validation file, you can see where your validation data is located. You can also change the visualization. By this, you have to double click on your validation Landsat image file symbology, and then here select different color. So for example, in select field color dialog box, you have to select any color that you would like. In my case, I would like to see my validation data in red, so I click OK, apply, OK, and here you go, my validation data is in red. And in such way, you can also see where exactly your validation data is located in your image. You can locate it. So if you zoom into the image, you can see where the polygons that you have selected for validation are located. Something that I have to mention for you as well, as you remember, we have created, now I'm moving to the look of semi-automatic classification plugin. So we have created our validation data within this semi-automatic classification plugin training input doc. What is important and what I haven't mentioned in the previous video, that once you finished with creating your validation or training data, this is the same. You have to go to the layers view, and then you have to actually save your data. So you have to right click on validation or training input, depending on what you have created, and then here there will be some icon on the right, like a small screen. You have to click on it. You have to give a name for the data. For example, training Landsat 85, and you have to basically also navigate to the folder here. You can do it by clicking on this button here. Yes, the folder is correct for me. I click OK, and then the layer is saved. And this is very important, because if you forget to do it next time when you open your QGIS project, then you may be not able to find your validation or training data. So don't forget to save your validation and training data afterwards when you have created them in semi-automatic classification plugin, because the way it is created currently in this plugin is that the files are temporal files but not permanent files. Okay, that was a small interruption of our main goal. Now we can proceed with accuracy assessment procedure. For this, you have to go again to the main look of your semi-automatic classification plugin, which you can find by clicking here on the top corner of your QGIS desktop called semi-automatic classification plugin. Once you open this dialog window, you have to go to the post-processing, and here you will see the first menu option will be actually accuracy. So for accuracy assessment, we have to have two input. We have to select the classification to assess, and let's select our maximum classification output, maximum likelihood classification output, and we have to also to select the reference vector or raster. In our case, we have a reference vector layer, which is our validation data. As you can see, I can't see it in this list, so I have to refresh. And now I can see my Landsat validation Landsat input data. Here you have to select a vector field. And this is important. Remember, I was telling you not once that it is very important how you name your macro class ID and class ID. So be careful with this. Depending on how you were naming your macro class ID and class ID, you have to select the correct field for your accuracy assessment. So if you have different class IDs from macro class IDs, you have to select then those column in your vector data attribute file, which will correspond to those classes that you were using to create your classification. So in my case, since I was naming my macro class ID and class ID the same, it doesn't matter. Well, basically that's it. We have to click then run, and there will be a dialog window where you have to name your output, and you click save, and the classification accuracy assessment is running. The output of the accuracy assessment will be the accuracy assessment report, which is delivered in the form of the table. And now let's have a look together on our accuracy assessment report. I will explain you how to interpret it, which will be very helpful for you. So what you can see is some statistics, basically different error matrix codes, reference and classified codes for classes. In our case, they are matching, which is good. Then you can also have some statistics, how many pixels were analyzed according to references. Then there is a error matrix based on the pixel count, which is a very nice output, and you can use also this output, for example, to compute your own accuracy assessment measures. How to do it? If you want to do it manually, you can see my video on accuracy assessment, where I actually explain how to compute such important accuracy assessment measures as overall accuracy, users and producers accuracies. But in QGIS with semi-automatic classification plugin, the good news are that you don't need to do it by yourself, as the program automatically compute all the measures for you. So here on underneath area-based error matrix, you can see there are producer accuracy values and user accuracy values. So basically, let's have a look on these values and talk about how we can interpret it. So the producer accuracy for the class 1, here you can see class 1 was 85%, or actually even 86%, which is very good and quite accepted, which means that our producer accuracy for class 1, which is vegetation, was 86%. But if you look at the user accuracy, it was only 44%, which is very low. How can we see it and interpret from our error matrix? Let us again for a second go back to our error matrix, which is located here in the middle of the window. You can see that our on the column names refer to the reference data, while the rows names refer to the classified image. And for the first class, on the interception of the classified and reference data, we can see that 411 pixels were classified from the reference data set as vegetation. Yes, so this is quite good, because overall total number of the pixels that were assessed were only 416. At the same time, we can see that only from the overall from overall classified pixels that were assessed from the map, only 411 were classified as vegetation, while 533 pixels which were classified as vegetation belong to the class 3 on our reference. Yeah, here you can see it here. So which means basically that from all 944 pixels that were analyzed and were present in the reference data and were marked as vegetation, only 411 were basically vegetation, but 533 were marked by me in validation data as water, which of course means that there was a misclassification, and therefore you can see that our user accuracy is very low. It's 44%. Well, let's move to another class. The second class was soil, and in case of soil, we have very good results. So both producer accuracy and user accuracy are almost 100%, which is perfect. So which means that this class was mapped quite accurately by our classifier based on our training, based on our validation data. The third class is water, and this is the class which has most the problem. The producer accuracy is only 7%, while user accuracy is 38%, which means basically that this is a class which performed the worst within all our classified classes. And of course, this all resulted in an overall accuracy which is only 47%, which of course unacceptable. Yes. Why we have received this kind of results? Well, as you can see from our image, it was quite difficult to see where we have water areas and where we didn't have water areas, because as I have explained you in the video about validation data collection, in this image we have a lot of dry water channels, so dry river water channels, which I didn't clearly mapped for myself whether it is a water or vegetation. So this is again comes to the question how it is important for the expert analyst to define land cover classes that should be mapped. So how should we proceed with this? Well, basically, having done this accuracy assessment, it becomes obvious also that our classification results are not suitable, that our training data have to be refined. The same should be done with validation data.